ladies and gentlemen, boys and girls, my name is Mr. Lu and you're welcome to Mr. Lu Scienceworld. Today we're going to look at derivatives of a function. And what about a function are we going to look at? We are going to look at trigonometric function. So that when we're given a trigonometric function, how are we going to solve the problem? That is what we're going to do with right now. So let's begin by solving a typical example. Okay, let's assume that we are given a question that y is equals to f of x is equals to tan x, and we are told to determine the derivative of this function. Okay, so it means that we want to find the y dx, okay, or f prime of x. That is what we want to look for. What are we going to do and how do we solve the problem? Okay, so given this problem, all we need to do is to try and see how we can transform the tan into what? A ratio of sine and a cos, so that we can apply the quotient rule in solving the problem. So let's look at it and see. Right. And remember, we've learned about the quotient rule and the chain rule. So if you have forgotten that, please just go and watch our previous videos so that you will remind yourself of that before coming back to this again. Alright, so let's see. We will straight away just take it as, okay, we are having the y is equals to f of x to be equals to tan x. Okay, let me quickly just change it from this point to say, okay, we are having our tan x, and tan x can be transformed into sine x over cos x. And when I have this now I can solve this problem by applying what? The quotient rule. So I have transformed the whole function to y being equals to sine x cos x. Then from here, I will just try and represent each of the function with a certain variable. So I'm going to say that v of x, I'm using v of x to represent what? Cos x. And I will use u of x to represent sine x. And once I have gotten this, the next thing to do is to take the derivative of each of these functions. So I'm going to take the derivative of, so I'll take dv dx, that means I'm differentiating v with respect to x, and that is going to give me negative sine x. And I will differentiate du dx, so I'm differentiating u with respect to x, and that is going to give me cos x. And when I have done this, now I can apply the quotient rule to solve the problem. So to apply the quotient rule, it is straight away just going to give me the y, the x is now going to be u. I'm going to have v du, the x minus u, the v, the x, all divided by what? V squared. It means that here I'm going to take the u function and I'll multiply it by the derivative of the v, and I'll multiply by the derivative of the u function. And I'll take my u and multiply by the derivative of of the v function. And then I'm going to divide all by the square of the v function. Alright. So straight away, let's do the substitution here. The y, the x is now equals to v is cos x, and I'm going to multiply that by du dx, and du dx is also what? Cos x minus sine comes in there, and I have u, and u is sine x multiplied by, I have dv dx, and dv dx is negative sine x, and I'm going to divide all by the v function, and v function is cos x. So all squared. And when I have this straight away I will simplify to have the y dx being equals to, when I multiply these two, I'm going to have this square of the cos, and negative will multiply the negative to give me positive, and I'm going to have sine x multiplied by sine x, so that I'm going to have sine square x, and I'm going to divide all by cos square x. And once I have gotten this, remember that there is an identity. And what is that identity? There is an identity that says when you have cos squared x plus sine squared x, that must be equals to what? It must be equals to 1. So we can just simply see that, but my cos squared x plus the sine squared x is equals to 1. So I'm going to replace that with 1, so that my dy dx is now equals to 1 over cos squared x. Now I have gotten this. Again, we can also remember something, because something beautiful is coming out here. We have a 1 over cos squared x. We can also remember that if we are having 1 over cos x, that will simply give us what? Sec x. So 1 over cos squared x is simply going to give me the square of that. So I'm going to have the y, the x to become what? Sec squared x. And that becomes the derivative of what? Of the tan x. So that means that whenever we are given tan x and we have to find the derivative of tan x, it should give us what? Sec squared what? Sec squared x. Alright, let's try another question and let's see. Let's try another question. Alright, let's look at another question, and the next question that we're going to have is y is equals to f of x is equals to cot x. Alright, so we are given this cotangent, and we are told to find the derivative of this. So we want to find the derivative of the function that we are given, okay, or we're just looking for the y dx or that. Alright, good. So once we are given this and we want to solve this problem again, we will try and transform that again. So we're going to have y is equals to f of x being equals to cot x, and that is equal to, this can be written as 1 over tan x. And we know that tan x is also sine over what? Over cos. So these can simply be transformed to become 1 over sine x cos x. And we can then write that beautifully to make it look more simple and more presentable way by saying it is what? Cos x divided by what? Sine x. And again, once we are here, we can then apply our quotient rule to solve this problem again. So I am still going to have my v of x to be sine x, and then u of x to be cos x. And I'll find the derivative of each of the functions. And this is giving me cos x, and then I'll find the derivative of the u dx, and that is also going to give me negative sine x. Now I have gotten this, I need to apply quotient rule, and to apply quotient rule, we know it is going to be the y, the x now is going to be v, the u dx, minus u dv dx all over v squared. So I need to do the substitution here and solve for the problem. So let's do the substitution. That is going to give us the y dx is now going to be equals to v is now given to me here sine x multiplied by du dx, and du dx is negative sine x, okay, and then we have a negative sign, and we have u, and u is cos x, so cos x multiplied by the v dx, and the v dx is cos x again. So cos x, and we are going to divide all by the v, and v is now sine x all squared. And now let's try and simplify this problem and see what we're going to have. So we're going to have the y dx to be equals to, this will become negative sine squared x minus cos squared x all over sine squared x. And once we have gotten this, we can see negative here. So let's try and factor out the negative sign and see what we can do. So if I factor that out, I'm going to have the y dx to be equals to negative out, and I'm going to have cos squared x plus sine squared x divided all by the sine squared x. And again, we come back to where we started from the first question again. We can see that this will be equals to 1, so therefore we can have our dy dx, the y dx should simply become negative 1 over sine squared x. And remember, when we have 1 over sine x, that will give us what? Cosecant. So if we have cosecant and the square of that, therefore we can just simply conclude to say that our y, the x is now going to be negative cosecant squared x. And that becomes the derivative of the function that we were given. So whenever you are given any problems like this, which is a trig function, you need to try and apply the rules of the trig ratios that you know. Simplify them and make it the way that before that it will be very easy for you to take the derivative. And then you apply a quotient rule or a chain rule or implicit differentiation. It depends on the kind of function that you are given, and then you'll be able to solve the problem. Thank you very much for watching this video. Please, if you have not subscribed to our YouTube channel, please do subscribe to our YouTube channel so that anytime we release any new video, you'll be the first person to watch it. See you next time.